3.4 inequalities in 2 variables. So if you thought doing it with 1 variable is fun, yeah. This one is, it's not as fun. But I also don't think it's as hard. So that's just my opinion.
But you're a math.
I know, I'm a math nerd, so it kind of, it doesn't help. When graphing linear inequalities, we always have to test the point after graphing the line.
Photoshop is free.
Okay.
If the point makes the inequality true, then we shade that direction of the line.
So you can
Oh.
go through this.
Yeah, so on this linear inequalities, which you hopefully have seen, the lines will be dashed sometimes they're solid. The lines are crucial, but like it says up here, we're gonna have to find a point that's not on the line, because the points on the line are either going to make the inequality either true or false directly, meaning it like as though we're at an equal sign. This doesn't have to make sense. We'll see it because you guys are giving me that look. Now, when we test a point not on the line, it may make the inequality false, and we are looking back at the inequality, but we solve it as though it was true. We don't really care about the inequality at that point. But when we test, we are using the actual inequality. If it's false, you shade the other side of the line. If it's true, you shade that side of the line that the point is on. Now, test a point that's convenient, meaning 0, 0, for example, because replacing x's and y's with zeros makes the calculations easy. Try not to use decimal values or fractions, because those suck and they have destroyed lives. Another easy value would be like 0, 1 or 1, 0. Have a 0 in there somewhere, but make it easy on yourself, okay? But you have to choose points to test yourself. So that's the point of this exercise right here. They've given us an equation. Are these ordered pairs going to make that inequality true or false? We'll find out. But if they were to make these true, then we would expect to be shading that side of the line, wherever that point is. Of course, we're not graphing because we're just checking, right? But again, this is something you would check at the end for testing values. So I'm gonna go to the regular equation, the negative 2x plus 3y. Now it should be greater than or equal to 3, right? But I'm gonna replace the x and the y with the x and y that they give us, which in this case, the x is negative 1 and the y is 2. Well, 2 plus 6, that's going to be 8, is greater than or equal to 3. This is true. So, since that is true, it then is a solution, which I'll just box it in. This is not really to just be like, is it going to be true or false? It is, but then on the actual graph, you would be like, all right, now I know I can shade that, whatever side of the line negative 1, 2 is, that's the side that I would be shading, okay? But let's try it with 0, 1 then. So that's a negative.
You'll show stand graphs.
So negative 2x plus 3y should be greater than or equal to 3. But they've given us new x and y values. So let's place those in there. So the x is 0. See, there's a 0 value. That's going to be nice because that's just going to 0 out. This is 3 is greater than or equal to 3. Now this one, notice that it's equal. That means it would be on the line. So this would not actually be a point that you would test. But since it's an equal part there, we would say this is a solution. If it was just greater than and not the equal part, then we would say it's not a solution because 3 can't be greater than 3. Just understand this one would be on the line. So let's try this one too. And again, they've given us an x and a y value. So the x value is 4 and the y value is 1. If I put this in negative 8 plus 3, it'd be negative 5. Now it's saying that negative 5 is greater than or equal to 3. This one's false. Negative 5 can't be, it's not only is it not equal to 3, but it's also not greater than 3. So this one is just false all the way around. Now let's try the next one. So negative 2x plus 3y is greater than or equal to 3. Let's replace the x with 2 and the y with 3. Okay, so that's a negative 4 plus 6. Negative 4 plus 6 is 2, right? 2 is greater than or equal to 3. I think that's false, isn't it? No, that's 9. That's why you should use the calculator. No, bring it on, man.
No.
So it's 5 is great. Yeah, now it's true. That's why, again, use a calculator for this stuff. So graphing linear inequalities, we're looking at 2 variables, right? Y's and x's. So I recommend putting these in the slope-intercept form. Okay, so if it comes out in standard form, I'm going to change it to slope-intercept form, although you don't necessarily have to. You can work with the y and x intercepts if you prefer to. Just sometimes they're fractional and that kind of sucks. So we're going to change the equations into slope-intercept form because then we can graph the y-intercept and we can use the slope to find all the other points. That's the only two things you really ever need to graph a straight line, other than just 2 points. But since I'm doing it by hand, I'm going to show all the points. Now, like you're saying, is if it's less than or just greater than, remember, no equal parts, we're going to have it dashed or dotted, however you want to put it on there, because I'm doing it by hand. If it has the equal part, so less than or equal to or greater than or equal to, then it's a solid line. The reason that is because then all the points on the line would be equal to, and that then would make them true statements. But the dotted line tells us the values on the line would then be false. But we need a line because that's a transition from falsefulness to truthfulness, okay? And that's where we need the third and fourth steps here. Choose a point on the either side of the line because we're going to test it. And then once we test it, if it's true, then we shade that side of the line. If it's false, we shade the other side of the line. So truth tells us shade. False tells us shade the other side. Maybe that's more confusing, but hopefully an example will help tell. So the shaded areas, whatever they are all true. All the points there, all the ordered pairs in that area are true. So again, we're looking at infinite values that make the infinite number of ordered pairs that make the inequality true. But the shaded part makes it so that we can communicate that easier and faster. Okay, so this is nice. They've given us the equation in slope-intercept form. So I know the 2 there is my slope, which I will show. I know I need my rise and run right there, right? So it's 2 over 1. The 2 is positive, so it'd be up 2. The 1 is positive, so that'd be to the right 1. Now, I probably should have started with the y-intercept, okay, because that's our starting point on the graph, which would then be 0, -1. Okay, now this is slope-intercept form. Y equals mx. M is the slope. Mx plus b. B is the y-intercept. It's a -1 because of the minus sign right there. So 0, -1. Let's go ahead and put that on the graph. 0, -1. There we go. And then I'm going to graph the rest. I'm just going to put points on there. I'm not worried about if this is solid or dashed yet. I'll get there. But I'm going to go up 2 to the right 1. So up 2 to the right 1. That's the next point. Up 2 to the right 1. And so I'm showing all the stair steps, although you don't necessarily have to, and most students don't when they're doing it by hand. Of course, on the computers for the assignments, you just got to put 2 points in and it will graph the line. But now that I'm doing this by hand, I have all the points that I can put on the graph. I've just got to worry about if my line will be solid or dashed. And I see I've got the equal part on the inequality there, so it's going to be a solid line, which again communicates that all the points on the line would make the inequality true. So let's see if, well, let's try some technology to help me out because I need it. That's better. There we go. Okay, so that's my line. It is solid and it's fairly pretty. But now that we have this on the graph, that's just the parts that make it equal. We now need to take care of the ordered pairs that would make the inequality portion, the greater than portion, a true or false statement, I guess. Now, if the line is going through the origin, you can't use that, but this one's not. So I know I'm gonna use the origin right there. It's just barely off the line, the origin at 0, 0. That's going to be my test point. So what I'm going to do is I'm going to go back to the original inequality. Y is greater than or equal to 2x minus 1. And then I replace the x and y with the x and y value that I've chosen from my test point. So the x value is 0 and also the y value is 0. We'll go ahead and solve this. And that will tell me if I need to shade on the side of the line, which for me I'd say this is to the left. Some people would say up, either way. But from this I get 0 is greater than or equal to -1. Now, from what I know, which isn't so much, but that's true, 0 actually is bigger than -1. It doesn't have to be equal to. In fact, we don't really care about the equal part because that's the green line right there. So since it's true, and my point I would say is on the left, that means I got to take my shading tool. Let's see if I can do this with less shading this, but there we go. This side of the line I just shade in. Now, I don't really have to get all of it because I'm just doing it by hand, but this tells us, again, every ordered pair that's on this side of the green line there would make the original inequality a true statement. Okay, so this one just says y is less than or equal to 4. Most students don't like to see this as slope-intercept form, but you could. Just remember, if you get a y equals statement, if you have a y equals just a number statement or equation, it's a horizontal line at the number. Okay, so this one, I see the number is 4, and so it's a horizontal line, and it's on the y, it's even saying what axis it should be on. On the y-axis, I find 4, found it, and then we're just looking at a horizontal line across here. And the reason that is because all of the ordered pairs on this line have a y value that is 4. Now you notice that I made this a solid line. I should have checked first, but it's equal to, so I'm gonna make this a solid line either way. Yeah, to finish this off, we're gonna test a value. I'm gonna test 0, 0, because it's not on the line, so I'm going to test the origin at 0, 0. But you'll notice in the equation, right, which is y is less than or equal to 4, there's not even an x value to replace. But I think that should make it easier because I just got to replace the y value with 0. 0 is less than or equal to 4. That, from what I know, is true. And since the point that I'm testing, I'm saying is below the line, that means I'm going to go in and shade below the line. There we go. As x is greater than 3, so we know if we have x is compared with some number, even if it's equal to. So if the equation has the form x equals some number, just the number, then we have a vertical line at the number, and also, well, I'll finish this off. So it's going to be a horizontal line at the number on the x-axis. So again, we know it's on the x-axis because it says x is comparing some numbers. So I go to my x-axis, I find 3 right here, and I know I'm going to have a vertical line at that 3 right there. So is it going to be solid line or dashed? It's dashed because it's just, yeah, it's just greater than. So here's my dashed line. It's not so great, but it's not my worst effort. Maybe that's dotted. It doesn't matter. And again, the dashed or dotted line, dotted for me, tells us that all the values, all the ordered pairs on that line would make this inequality an equal statement, but the equal part is false, so it's a dashed line. Next, I will do the same thing as we did on the last one. I will test. I like to test the origin. But if you wanted to test like -10, 10 right there, you could. I'm not going to do it. So test the origin always if you can. Again, it just has to not be on the line. But again, on the equation, which is x is greater than 3, there's no y value to replace. There's only an x value to replace. And I've chosen an x value that's 0. 0 is greater than 3. That's false. Now, since it's false and it's on the, I'm going to say it's the left side of the line that I've drawn, that means I now need to shade the other side of that line. So I just fill it in. I mean, it looks better when you guys do it on the assignment because it's technology and it looks pretty. So here's the thing on the assignment as well. So before you graph the line, you have to choose if it's dashed or if it's solid. After that, you just choose 2 points. So like you could chose 3, 0, and then any other point on this line, and then it would have graphed the dashed line. But in addition to that, then you just choose any point over here. It doesn't matter which point. Now that we know that you need to shade the right side, just click anywhere on this side of the line, and it will shade that side of the line for you. Well, as fun as that was for math nerds like myself, we now get the opportunity not to graph one inequality, but 2. Think of all the joy. Well, graph 1 inequality on the line, and again, you're going to test a point on that side of the line. Now, you need to keep track of which side you should shade. Okay, so again, if it's true, you shade that side of the line. If it's false, you shade the other side of the line. But you need to keep track of that because we got to shade the second line. We got to shade for the second line. So you're going to graph the second line after that, and then you got to test a point for that line as well. Now, the final shading needs to occur where both shadings intersect. And that's where, I mean, you can show shading twice, which I will show you how to do and get credit on an exam. I'll show how it would look. I will show how it will look on the assignment as well, because it gets all colorful and pretty, but not quite so much on the exam unless you guys bring.
Colored pencils?
Yeah, so some students choose to bring colored pencils or colored pens or crayons. Yeah, I have seen crayons as well. Okay, so let's graph this. We got y is less than 2x plus 2. So this one's nice. It's already in slope-intercept form. I'm going to graph this one in red, and I will shade it in red as well. So the first one that I'm doing right here is based off of what you will see on the assignment too. All right, so on this one, we have the coefficient of x. That's my slope, and then we got the y-intercept. That's a positive 2. So I'm going to start at the point 0, 2 for my red line. This is going to be a dashed line because it's not equal to, but we know that the slope is 2 over 1. It's 2, but I need it as a fraction so I can see my rise and run, right? So it's going to be up to the right one. I guess we've already done one with up to the right one either way. So from there I go up to the right one. I'm not going to show the steps on this one because it needs to be a dashed or dotted line. And I can continue this pattern in both directions, okay? So I'm just going to kind of make it dotted. Since I'm doing it by hand, it's not so perfect, but it'll work. Okay, so this is my line, and I'm now going to test the point 0, 0. It's my test point. And then I will see in the inequality y is less than 2x plus 2 if it is a true statement. So replace the x and the y with zeros because we chose the origin, which makes this convenient. And then you end up with 0 is less than 2, and that's a true statement. Now I need to keep track of the side that I shade on, but again on the computer for the assignment, since this 0, 0, I'm going to say it's on the right side of the line, we need to shade over here. You would just click on that side and then it would just shade it for you, okay? So this isn't quite what it would be like on the computer, but I'm trying my best. So there we go, and I stayed within the line, so kind of. Next. So let's go to that next one. I'm going to do this one in purple. I see that from this -1, I have a y-intercept at 0, -1, which is right here on the graph. This will be a dashed or dotted line because it's not equal to the y, but I do have my slope there. And I'm going to show it as -4 over 1. So that's going to be down 4, and then to the right 1. I've done better handwriting, but that'll do. So down 4 to the right 1, down 4 to the right 1. It gives me these points, but I can reverse the staircase and go the other direction, up 4 to the left 1, up 4 to the left 1. And again, this will be dashed or dotted, however you want to do it. Mine's dotted, I guess. Something like this. Let me see if this helps. So from my y-intercept, I went down 4 to the right 1, down 4 to the right 1. That stair step, I just copied the other direction. So I went left 1 up 4, left 1 up 4. So it's the same stair step, but now it allows me to put these other points on there, and then I just connect them with the dashed line. So now I'm going to take the equation, y is greater than -4x minus 1, and I'm going to use the same test point. Okay, so I'm going to test at 0, 0 right there, and that means I'll replace the x and the y with zeros. So x is 0 and y is 0. This tells me that 0 is greater than -1, which it's true. So for the purple line, and again, you got to be able to separate this in your mind. The purple line, I'd say it's in this section right here. So when you go to put this in, you're looking for I guess kind of the cross section there of the two. So I'm gonna So kind of like this. So what you'll see on the computer, right, is you'll see this part's red and this one's purple. Usually what it'll do is it'll give you a new color for this section automatically, so you don't actually have to like regraph it or just kind of focus in on one of the sections right there. So the green is really the only area. Again, I'm trying to demonstrate what you'll see on the assignment, but if you're doing it by hand, I would recommend doing it in a different way, which I will show. That's an important part. The green will make both inequalities true, not just one, both. And that's the part we need to remember with systems, is that solutions need to make both equations or inequalities true. Just thought real quick is, if let's say you chose a point 0.8 right here, 0.8 would make the purple true, right? Which is this inequality true, but it's not shaded for the red, so it would make this one false. A solution to a system has to make both inequalities true. So if you chose like 10.0 right here, it would make both of these inequalities true, both. And again, if you chose one in this section, it would make the red one true, but not the purple one, so that's no good. If you chose anything in this section, it would make both false, which is doubly not good. All right, two equations. Now I'm gonna do this one as though you were doing this on an exam and you didn't have colored pencils. You just had a pencil or a pen, okay? So I'm gonna do it all in black, which it gets a little messy, but it's doable.
Can you do it in?
Let's do it all in green, at least so we can see this stuff. Yeah, fair enough. All right, what I'm gonna do is I'm gonna take that top equation, and like I said, I don't like to mess with that standard form linear equation stuff, so I'm gonna change that into slope-intercept form. So negative 2x plus 2y is greater than or equal to negative 8. Okay, so to do that, we need to isolate the y, so I'm gonna have to zero out the 2x by adding 2x to both sides. I put that beneath the negative 8, even though it's not a like term, so I know I can't combine them. So I'm gonna keep them separated, right? 2x minus 8. I just want the x term to be first, so it mimics slope-intercept form, right? So divide all the terms by 2 now to make that a 1y, which equals greater than or equal to, I'm gonna show the 1x and then minus 4. You don't have to show the 1, but you can. I'm just showing the 1 so we can actually see the slope. And yeah, I divided all the terms by a positive, so it's not going to change the inequality. But right there, I got the negative 4. That's my y-intercept at 0, negative 4. I'm gonna put that on the graph. And then my slope for this one is 1. I'm gonna show it as 1 over 1 so that I know I'm going to go up 1 and then to the right 1. From the y-intercept, which I've already put on the graph. So this is gonna allow me to put a lot of points on the graph. This one is going to be a solid line. So up 1 to the right 1 is the next point, up 1 to the right 1, and then we get all these other points there. This one has a lot of points on the graph, so I'm not gonna show all the stair steps. But yeah, I can mimic the stair steps backwards this way to get these other points too. And again, I'm just putting all these on the graph because, I don't know, I can, and I'm doing it by hand. So now that I've done that, I now need to make my straight line. Hey, I'll call that a success. Is it perfectly straight? No, but I don't care. Some students do bring, yeah, I know, some students will bring a ruler for the exams. That's fine. I just don't care. So now that I have that, I'm going to test the point 0, 0, because again, the line is not on the origin at 0, 0. So I'm going to test 0, 0 in the original inequality, which is negative 2x plus 2y should be greater than or equal to negative 8. So I take my x's and my y's, I replace them both with zeros, which is an easy calculation because now it's just zeros greater than or equal to negative 8. That right there is true. So like I said, if you, doing this on an exam, I would just want to keep track that I'm shading on this side of the line. So here's what I usually do is I just make some lines out, you know, just kind of extending from the line that I've drawn. And again, if I see this on an exam, I understand what's happening, okay? So that's for just this line that I've already drawn. Now I need to graph the other inequality. And so this plus 4 right there tells me that I'm going to have an y-intercept at 0, 4. So I put that on the graph, 0, 4. And then my slope there is showing, I'm going to make it -1 over 3 because I always like my denominators to be positive so that I know I'm going to the right. So the -1 tells me to go down 1. And then the 3 being positive tells me to go to the right 3. Okay, so down 1 to the right 3. There's my other point, down 1 to the right 3. I see an intersection, and then down 1 to the right 3. I can copy these stair steps to the left. Left 3 up 1, left 3 up 1, left 3 up 1. And this one right here is going to be a dashed line, right? So I've got my points on there. Can do a dashed line like this. That's not too bad for me. All right, but then again, it's not going through the origin, so I know I can test the origin with the equation, right? I'll do it over here on the right. Y should be less than or equal, just less than, sorry. -1/3 times x, which I'm going to replace with 0, plus 4, and then, yeah, replace the y with 0, too. So 0 should be less than 4. Yeah, that's true. Now, again, 0, 0 is below, I'd say below this dashed line that I just drew. And so I would show that everything below it is true. So I'm even though right now I know that this part is false, I can keep that there just so I know where to shade. And remember, it needs to be shaded where both parts would be shaded. And I can see that it's shaded below the dashed line, above the solid line, so it's this section right here. So how would you show this if you just had a pencil? Just any way that you want to, like if you want to just extend these down in here. But notice now I'm not going past these lines, otherwise it looks really nasty.
You're really just looking for that shape, right?
Yeah, somewhere in here. So yeah, some students like to cross hatch it. Some students like to just make it like, you know, like actually shaded, like thick and thin lines or something. I don't really give a crap. It just, I just need to be able to tell that you know that it's this section that should be double shaded or cross hatched or whatever you want to say. Now, yeah, let's say you graphed 2 lines. Just as an example, this line. And, well, let's pretend that these are parallel. Now, let's say that you shaded this side right here and this side right here. There's no intersection. There's just no solutions for something like that.
Because they're parallel lines.
Now, it's not just because they're parallel lines. It's because they're shaded in the opposite directions. We need double shaded areas for the solutions. Now, if we had something like this. Now, on the other hand, if we had, let's say that we had parallel lines. Let's do 2 new parallel lines. This one and this one. And even though these aren't exactly parallel, we'll pretend like I've done a good job. If the shading, let's say for the blue line was this way, right? And then the green line was this way. Okay, then you got in between those 2 lines would be the solution. There would be a solution set.
What are the odds of something like